Hey everybody, I'm going to go over how to find valence charge in this video. So I just want to keep in mind, I'm going to tell you kind of how to find it exactly. But as you do more and more of these, you're going to start recognizing patterns here. So you won't necessarily be needing to do the math every single time because you'll look at it and just recognize it as that charge. But at the beginning, it's really, really nice just to be able to know, like, this is exactly how you do it. It's very straightforward math. It's like very simple arithmetic. So hopefully everybody's going to be able to hang on here. But I just want everybody to be clear, like just kind of look for the patterns and you'll start to look at things, go like, oh, an oxygen with 3 bonds and 1 lone pair is going to be this charge or whatever. So you'll get there. It's just going to take some time, but I think it's helpful to understand how to exactly get formal charge. So we're going to talk a little bit about how you find it. So to think about formal charge, you really need to look for these 2 items. So the number of valence electrons for that atom and the number of owned electrons on that atom. Okay, so the valence electrons, this is what you've used before. It's just from the periodic table, you know, how many electrons are in that outer shell. And so that's just going to be the very same valence electrons that you dealt with in Gen Chem. So the owned electrons, I don't even know if anybody really talks about it like this, but it's really just like how many electrons does that atom get to call its very, very own. And that's kind of the weird way of saying, like, we're looking at half of the electrons in bonds, in considering that an atom is evenly sharing those electrons that make up the bonds. And then all the lone pairs, as in those lone pairs are not getting shared with any other atom. They are just solely on that atom. Okay. So if we look at this carbon, for instance, these 2 lone pairs are fully owned by that carbon. But then depending on what's out here, these bonds, the carbon's only really getting to hold half of those electrons. So if each bond has 2 electrons, then we're thinking about half of those 6, which is 3. Okay. And then for valence, remember, we're just going to be looking at the periodic table here. So we're really looking at 3, 4, 5, 6, 7, 8, right? I always just kind of take off that 1 and then that's your valence electrons. So for carbon, we're looking at a valence of 4. Okay, so we've got 4 in all of these cases if we're looking at identifying the carbon formal charge here. Okay, so and then we said that we had 5 because we've got 1, 2, 3, 4, 5. And basically you're just going to be counting 1 of each bond, right? And if you have a double bond, you'd be 1, 2 if it was double over here, for instance. Okay, so for owned, that's 1, 2, 3, 4, 5. Let me just. Okay. And the way that you calculate the formal charge, it's just simply the valence electrons minus the owned electrons. Okay, so 4 minus 5 is -1. So this carbon is a negative charge. So we would just put a little negative sign next to it. Okay. Very, very rarely are you going to come across an instance where you have like a 2- or something like that. Generally, if you're getting into 2- or 2+ world, you should rethink your structure, and there's probably a different way because it's very, very rare to see those multiple charges on small molecules, especially on a single atom in a small molecule. Like, you're just not going to make an O2-. It's just not going to happen. So if you start seeing yourself getting those formal charges, A, check your formal charge math, make sure you're doing it right, and B, check your structure and make sure that you drew it right. Those are usually the 2 biggest issues that I see. Okay, so for this carbon, I don't have any, I've drawn in all of the bonds. Okay, so it's I want to be very clear that I don't have invisible H's that we're missing right here. So it just has those 3 bonds. So if we're counting up owned electrons, we've got 1, 2, 3, because from 3 bonds. Okay, so 4 minus 3 is +1. So this is a positively charged carbon atom. Okay, it's a carbocation. This one is a carbanion. Okay, of course they all have names. So this is a carbanion, carbocation. Okay, so this is a really interesting one. We will maybe talk about it in second semester, but I just wanted to show it for formal charge purposes. This is actually called a carbene. It has very specific chemistry associated with it. But let's just count out how many owned electrons it has. So it's got 1, 2, because we count all the lone pairs, and then one of each of the bonds, 3, 4. So 4 minus 4 is 0. That carbene is actually neutral, but count how many electrons it has total. It only has 1, 2, 3, 4, 5, 6. So it doesn't have a full octet, super reactive, but they're really cool. I did a lot of work with them. But I just wanted to show you for formal charge, like something can have not a full octet, but still be neutral. So watch out for those instances. Okay, and then our last one, we've got a carbon with 4 bonds on it. So 1, 2, 3, 4 owned electrons from that, excuse me. So 4 minus 4 is 0. That's just a regular carbon. So anytime you've got a carbon that has 4 bonds on it, you don't need to worry about formal charge, right? So this is always going to add up to that, no matter what kind of multiple bond scenarios you have going on, right? If you've got like carbon with a nitrogen, that's still a formal charge of 0. Right? Because I still have 1, 2, 3, 4 owned electrons and 4 valence. Okay, so let's look at it when we use oxygen and nitrogen. These are going to be the other ones that we're very commonly going to need to decide formal charge on. So for our valence electrons, let's just go ahead and get those dealt with right now. So oxygen has 6, nitrogen has 5. So let's fill those in. So 6, 5, 6, 5, 6, 5. Okay, so let's look at how many owned electrons are around this oxygen atom right here. So we're counting all of the lone pairs, 1, 2, 3, 4, 5, 6, 7. Okay, so it owns 7 of those electrons. So we're counting half the bond, all the lone pairs. So we are owning 7. So 6 minus 7 is -1. Okay, so that's what a -1 charged oxygen is going to look like. It's going to have 3 lone pairs and 1 bond. Okay, so our nitrogen here, we've got 1, 2, 3, 4, 5, 6. I should have highlighted that. So 5 minus 6 is also -1. That's your negatively charged nitrogen. Okay, for our oxygen right here, we've got 1, 2, 3, 4, 5, 6. There's our neutral. The next one that the nitrogen, 1, 2, 3, 4, 5. That's the nitrogen neutral. And then this guy with the 3 bonds on the oxygen, we've got 1, 2, 3, 4, 5. 6 minus 5 plus 1. That's our positively charged oxygen. And then our nitrogen, keep in mind this does not have any lone pairs. And the way to check that is you just count up how many electrons total are around it. So 1, 2, 3, 4, 5, 6, 7, 8. If we added a lone pair there, we'd get up to 10. That's exceeding the octet, which we cannot do. So this nitrogen does not have lone pairs on it. It just has 4 owned electrons. So that's also going to be a +1 charge on that nitrogen. Okay, so that's going to be a really key skill to learn, just in terms of getting comfortable with assigning those formal charges and starting to recognize some of those patterns.